Hi, my name is Kingsley Linus. In today's mathematics lesson, we'll be looking at the topic rational and non-rational numbers. By the end of this lesson, you should be able to define rational numbers. Secondly, you should be able to define irrational or non-rational numbers. Also, you should be able to identify rational and irrational numbers. And lastly, you should be able to determine the appropriate value of pi. Rational and irrational numbers. I'm sure these terms are not strange to you. Let's find out what rational numbers are. A rational number is a number that can be expressed as an exact ratio of two integers. On the other hand, an irrational number is a number that cannot be expressed as a fraction or a ratio of two integers. Now, two words are key in these definitions: ratios and fractions. What is a ratio? A ratio is the relationship between two numbers. A fraction is a part of a whole. When you have a whole and it's shared, you call one part of that a fraction. Now, mathematically, fractions and ratios are the same. Let's see more examples, or let's find out more about fractions and ratios. Basically, ratios are written in this form, while fractions in this form, where we have a numerator and a denominator. We read this as 1:2, and for fraction, we read this as 1/2. An illustration: if each desk in a classroom is occupied by two students, we can say the seating arrangement is one desk to two persons, and that can be written as 1:2. It is also the same thing as 1/2. Also, if Timi and Tola had to share an orange, the orange will be divided into two equal parts. Now, if asked what portion Timi gets, the answer is 1/2, and it can be written as 1/2. Now, expressing these as ratio and fraction, 1:2 means one desk is for two persons. And for the orange, we have one person gets a part of the whole orange. So that is half of the whole orange. Having said so much about ratios and fractions, let's go on to see what rational numbers are. First, we must note that all integers are rational numbers. The reason is because integers can be expressed as ratios of two numbers. For example, we have the number 8. 8 can be written as 8/1. It can also be written as -8/-1. It can as well be written as 8,000/1000. We have other numbers. A mixed fraction like 4/1/2 can be written as a ratio of two numbers, so it is a rational number. We also have a number like 0.211. It can be written as a ratio of 211/1000, so it is a rational number. And lastly, repeating or recurring decimals are also rational numbers. For example, we have 0.3. 0.3 can be written as a fraction 1/3. Using a calculator, 1/3 would give us 0.333, and it keeps going. Now, this number can be written for short as 0.3 bar or 0.3 with a dot, as you can see here. This is how we express numbers that are recurring or repeating. Now, any number you see that has any of these signs is a recurring or repeating decimal. And that qualifies that number as a rational number. Now, we have an example that says express the number 3.17 as a rational number. I'm sure you noticed the bars above the digits after the decimal. Now, let's solve this number. Let's express this number as a rational number. First, we can assign a letter to the number. So we say let n be 3.17. Now, because of the bar, it means 3.17 can be written as 3.1717 and so on. It keeps going. So it's a recurring decimal. The next step to take is to label that as equation 1. Then we multiply both sides of the equation by 100. So n multiplied by 100 gives us 100n, and 3.17 multiplied by 100 gives us 317.171717 and so on. Now we can call this equation 2. Then we move ahead by subtracting equation 1 from equation 2. When we do that, that is 100n minus n, that gives us 99n, and 317.17 minus 3.17 gives us 314. So we have 99n equal to 314. So to find the value of n, we can divide both sides of the equation by 99. And when we do that, we will have n equal to 314 over 99. So the number 3.17 bar can be expressed as 314 over 99. And that tells us that it is a rational number. Let's go ahead to find out what non-rational numbers or irrational numbers are. Before now, I said an irrational number is a number that cannot be expressed as an exact fraction or a ratio of two integers. We have an example like root 7. When you punch the number root 7 on a calculator, it will give you some long decimal numbers. The truth is, for as long as your device has so much space, the numbers will keep extending without repeating. So root 7 is an irrational number. Also, the constant pi is an irrational number because the digits after the decimal will keep extending without repeating. But usually, we use a fraction 22 over 7. 22 over 7 is a rational number, but it is actually an approximated value of pi. We have other numbers like the square root of any non-perfect square. The square root of any non-perfect square is an irrational number. For example, we have root 2, root 5, and so on. All of these are irrational numbers. Let's know some more about irrational numbers. An irrational number extends forever and is non-recurring. But we must also note that there is always at least one irrational number between two rational numbers. That means if we have one rational number, R1, and another rational number, R2, there exists a non-rational number between these two numbers. Also, the sum of a rational number and an irrational number is an irrational number. That is, R plus NR gives us NR. When we also multiply a rational number and an irrational number, R multiplied by NR, we still get an irrational number. Here are some examples of rational numbers as well as some examples of irrational numbers. Let's look at an example. Which of the following is a rational and which is irrational? We have 9 and root 8. Example 2 says express 8.3 as a rational number? First, we need to find out if 9 is a rational number. Now, the number 9 is an integer, so it can be expressed as 9 over 1. Therefore, we can say it is a rational number. How about the number root 8? Using the calculator, when we punch root 8, we will have a very long extending decimal number. This tells us that root 8 is an irrational number. Secondly, let's express 8.3 bar as a rational number. First, we assign a value to 8.3, x. So if x equal to 8.3, we can as well say x is 8.333, and it continues. Now we call that equation 1, and then we multiply both sides by 100. So 100x is equivalent to 833.333. That is our equation 2. Now we subtract equation 1 from equation 2 like we did previously, and that gives us 99x equal to 825. If we divide both sides of the equation by 99, we would have x equal to 825 divided by 99. So we have expressed that number 8.3 bar as a ratio of two integers, meaning it is a rational number. It's time to do some questions yourself. I have an exercise for you. Pause the video and try out these questions. I'm sure you are done. Question 1 says, among these numbers, identify the rational and irrational numbers. You are simply expected to indicate an R or NR. For A, we have R, R, NR, R, and R. Question 2 says express 3.28 bar as a rational number. The answer to this question is 325 over 99. If these were your answers, you are correct. Now, let's go on to talk about square roots in relation to rational and non-rational numbers. A square root is a number that when multiplied by itself yields another number called a square number. Now, square numbers are also called perfect squares. For example, we have root 4. 4 is a square number, and then the square root of 4 is 2. Now 2 is a rational number, so it is safe to say that the square root of a perfect square gives us a rational number. On the other hand, the square root of a non-perfect square results in a non-rational number. For example, root 11. 11 is a non-perfect square. And then when we find the square root of the number 11, it gives us a decimal number that keeps extending and is non-recurring. So this established the fact that the square root of a non-perfect square is an irrational number. Around 500 BC, a mathematician called Pythagoras made some studies about non-rational numbers. He found out that square roots of so many numbers are non-rational numbers. Let's learn some more about his findings. According to Pythagoras, when we have a square labeled ABCD, the square of the diagonal BC is equivalent to the square of the side AB and the square of the side AC, that is this part. So, putting in the values of those sides, we have BC square is equal to 1 square plus 1 square. And 1 square plus 1 square gives us 2. Therefore, The diagonal BC is equivalent to the square root of 2. Pythagoras discovered that it was not easy for him to find a rational value for root 2. But by drawing a diagram, it was easy for him to express his idea. As a result, he chose to call irrational numbers unspeakables. But he came up with a method by which we can find out a value or an approximate value for these irrational numbers. And this method is called trial and improvement method. Let's go further to find out how this trial and improvement method is used. We have an example that says, find the value of root 2 correct to two significant figures. Now, to solve that, we know that the number 2 lies between 1 and 4. As well, root 2 lies between root 1 and root 4. Now, the solution for root 1 and root 4 is 1 and 2, respectively. So it means the solution to our problem, that is the solution to root 2, is going to fall between the number 1 and 2. So let's try. Remember, we are carrying out the trial and improvement method. So a number that lies between 1 and 2 can possibly be 1.5. So 1.5 times 1.5 gives us 2.25. That is way above our desired value, root 2. Now let's try again, 1.4. That means we've stepped a bit down, more like an improvement. Okay, 1.4. 1.4 multiplied by 1.4 gives us 1.96. Now, this is a little lower than 2. Now, since root 2 lies between 1.4 and 1.5, the value 1.96 is much closer to 2 than 2.25. So let's go with 1.96. To the next digit, we are going to leave the first digit after our decimal and we move on to the next digit. So we try 1.41. 1.41 multiplied by 1.41 gives us 1.9881. Of course, this is still smaller than our desired value 2. We try again, 1.42. Now 1.42 multiplied by 1.42 gives us 2.0164. This is a bit ahead from the number 2. Recall that the question says we should find an answer correct to two significant figures. It means we are only interested in the first two significant figures. Ordinarily, you can see that our answer lies between 1.41 and 1.42. But since we are interested in the first two significant figures for our result for the number root 2, we can safely say our answer is 1.4 to two significant figures. You know, when you practice something more, it helps you to master it better. Let's try out an exercise. Pause the video and try out these questions. I'm sure you are done. The first instruction says write down the first digit of the square roots of the following. Number 1, 22. The first digit of each square root is the number 4. For question 2, the first digit of the square root of the number 71 is 8. The second instruction says use the trial and improvement method to find the value of the following correct to two significant figures. 1, root 23. The answer is 4.8. And for question 2, root 69. The answer is 8.3. If these were your answers, You are correct. Still talking about square roots, we have an example that says find the value of root 94, correct to one decimal place. Before we solve this, recall I mentioned earlier that between two rational numbers, you have at least one irrational number. Now, root 94 obviously is an irrational number, but it lies between root 81, which is a rational number, and root 100, which is also another rational number. So, the solution to root 94 is a number between 9 and 10. So, let's do our trial and improvement method. 9.5 multiplied by 9.5 gives us 90.25. That is smaller than 94. We try again. 9.6. 9.6 multiplied by 9.6 gives us 92.16. It's yet smaller. Again, 9.7. 9.7 multiplied by 9.7 gives us 94.09. This is a very close answer. So, because we are asked to find out our result correct to one decimal place, we can safely say that 9.7 is the solution to this problem. Here is a guide for you. When you are asked to find the first digit of the square root of an irrational number, do well to go through these points while carrying out the trial and improvement method. Recall, one of our objectives for this lesson is to find out the approximate value of pi. Let's go on to find out what the approximate value of pi is. Before we find out the approximate value of pi, it is helpful for us to know about a circle. A circle is a shape that has a point at the middle, having set of points around it that are equidistant to that point in the middle. In geometry, there are so many properties about a circle that we need to also find out. Let's see some of these properties. A circle has a center or an origin. A circle also has what we call the radius, r. And the radius is the distance from the center to any point on the circumference of the circle. Also, a line that cuts across a circle passing through the middle or the origin is called diameter. And lastly, we have the perimeter, which is the distance round a circle. It is often called the circumference. Here you can see the center of this circle, and then we have various points round this circle, and each of these points has an equal distance to the middle. The circumference is moving round the circle. And then here is an expression that shows us what d is from one point to the other point passing through the origin, and then from the middle to one point of the circle or the circumference is our radius. Let's talk about pi. Pi is a special number, and the value of this number is given by the ratio of the circumference of a circle and its diameter. Let's see how this relationship goes. It is important to know that pi is a ratio and its value is the same for any circle, and that is why it is called a constant. So wherever you find yourself, the value of pi remains the same. And I've mentioned earlier that the value of pi is a relationship between the circumference and the diameter. The relationship here is that 3.14 diameters of any circle is equivalent to one circumference. What do I mean? If we take the diameter of this circle, for instance, and we try to make that diameter go around the circle, you realize that we will use 3 of its diameters, and then we will need a fraction about 0.14 of that diameter to have our diameter go round the circle. So the relationship C over D is the value of pi. I mean, when we measure the circumference of a circle and write down its value as C and divide it by the value of the diameter, we would have a very long extending decimal number, like the one here. This is the value of pi. From this, you can see that pi is an irrational number. A mathematician known as Archimedes around 250 BC made studies about the value of pi and the properties of a circle. Let's see some of the things he found out. Archimedes had a circle, as you can see, and then he inscribed a square inside the circle and another square outside the circle. Now, according to his findings, he realized that the area of the circle is halfway between the area of the inner square and the area of the outer square. According to him, he found out that the area of the inner square can be given as 2r square, while the area of the outer square can be given as 4r square. Now, as we know, to find out the area of a circle, we usually use a formula pi r square. Now, if you observe pi r square and these two areas, you realize that r square and r square and r square are common in all the three figures. It means the value of pi is between the numbers 2 and 4. So we can just assume that the value of pi, or the first digit for the value of pi, is 3, which is correct. Of course, you know the value of pi is 3.142 approximately. Going on, Archimedes found out that the more the number of sides of the polygon you draw, the closer we get to the value of the area of a circle. You can see a circle between two polygons. Going on with his experiments, Archimedes realized that a 96-sided polygon gave him a very close value to the area of a circle. So he came with a conclusion that the value of pi lies between 3 whole number 10 over 71 and 3 whole number 1 over 7. Now, you don't have all this to bother yourself with. Whenever you are given a problem to solve, all you need to do is to use an approximate value, 22 over 7, or you use 3.142 as the value of pi. Here is where we come to the end of this lesson. But before you go, let's look at a summary of all we've learned today. First, a rational number is a number that can be expressed as the ratio of two integers. Secondly, we learned that an irrational number is a number which cannot be written as exact fraction or ratio of two integers. Next, we learned that a ratio is the comparison or relationship of two numbers written like a fraction. Furthermore, we learned that a fraction is simply a part of something, that is, part of a whole. Mathematically, fractions and ratios are the same. We also learned that pi is a special number. It is the ratio between the circumference and the diameter of a circle. The value is the same for any circle. Pi is given as 3.14 to 2 decimal place. Furthermore, we learned that all integers, recurring decimals, and square roots of perfect squares are rational numbers. We also learned that Pythagoras in 500 BC first discovered that many square roots are non-rational numbers. Non-rational numbers have decimals extending and non-recurring. Also, we learned that by approximation, we can find a value for an irrational number by a method called trial and improvement. And lastly, we learned that pi is a special number. It is the ratio between the circumference and the diameter of a circle. The value is the same for any circle. Pi is giving us 3.14 to 2 decimal place, or 22/7. I'm sure you know what time it is. It's test time. Question 1. The following are rational numbers except dash. A, -1. B, 5/7. C, 0.33333. Or D, √5. The correct answer is option D, √5. Question 2. All of these are irrational numbers except dash. A, √8. B, √4/9. C, √3.6. Or D, 3.1415926535 and so on. The correct answer is option B, √4/9. And lastly, question 3. Given that pi is an irrational number between √9 and √16, what method is used to find the approximate value of pi? A, trial and error. B, determining the square. C, trial and improvement. D, factorizing. The correct answer is option C, trial and improvement. Finally, this is where we come to the end of today's lesson. Thank you for your time. Till we see again in another mathematics class. Bye-bye.